Hi, in this video we're going to be looking at trigonometry and past paper questions pertaining to trig identities and also simplification. So our first question here is, without using a calculator, determine the value of the following expression: cos 350, sine 40, cos 440 and cos 40. If you inspect this, we've got cos, sine, cos, cos. So our first task is, we wish it was either cos, cos, sine, sine, or cos, sine, sine, cos. So we could use our compound angle formula. But let's start by using reduction formula. So if we look at 350, 350 is in your fourth quadrant, and we can write 350 as 360 minus 10. So we can rewrite this as cos, and remember in the fourth quadrant cos is positive, so it's cos 10. And the next to it is sine 40. So 40 is an acute angle, so we're going to keep that. Then you got cos 440, which is over a cycle. So we're going to say 440 minus 360, and that will give me minus cos. So we're going to take out 360 from here, and that'll give me cos 80. And then we've got cos 40. We're going to bring that down. So if we inspect this, remember, let's quickly write down the compound angle expression for cos, or we could write it for sine. So since we have more cos's on this end, and if we look at the first term, it's cos 10 sine 40. Now we need our angles to match. So using co-ratios, we can change, the first angle is 10, we can change the 80 as 90 minus 10. So that now gives me cos 10 sine 40 minus cos of 90 minus 10, that's a co-ratio, so it becomes sine 10, and that's cos 40. So you'll notice your angles are now matching. We have, and if we write this, rewrite this, we have sine 40 cos 10, and then we got minus cos 40 sine 10. And that is an expansion of the sine formula. If you think about it, I'm going to quickly write down the sine formula to jig your memory, that the sine of a minus b is actually equal to sine cos, which is sine a cos b, and minus will remain as minus, and we say cos a sine b. And if we go backwards, that's what we're going to say now, it's sine of 40, the negative comes down, minus 10, and that gives me sine of 30 degrees. And sine 30 is a special angle which gives me half. We're going to go on to another question, very similar to the first, and we're going to start by using reduction formula. It says 306. Now remember, that's in the fourth quadrant, and our angle formula for the fourth quadrant is 360 minus. For the first one, we're going to rewrite 306 as 360 minus 54. And remember, that's in the fourth quadrant where cos is positive, and that becomes cos 54. We're going to bring down the sine 84, and then we have minus 54. Remember what I said, minus 54. We're going backwards, which means we're in the fourth quadrant, and sine is negative in the fourth quadrant, giving you minus sine 54. Or you could just add 360. 360 minus 54 is in the fourth quadrant. Then we have sine 174, and that is in the second quadrant. We can write that as 180 minus 6. And remember, in the second quadrant, sine is positive. So we have sine 6 degrees. So you'll notice that the cos 54, sine 54 angles are matching. We have 84 and we have 6. So we can use co-ratios. Remember, co-ratio means 90 minus 84, which is 6. And the name from sine will change to cos. So we got cos 54, cos 6 minus sine 54 and sine 6. So just memory, to jig your memory a little bit. Using compound angles, if we have a minus b, you'll have cos AB, and then the minus changes to plus, sine, and we have AB. And if we go backwards, that's what we're going to do. It will be cos of a minus b, which is 54. And in this case, because we got a minus, the minus must change to a plus. Because if it was a minus, it becomes a plus. And that will give us a cos of 60 degrees. And that is a special angle. And cos of 66 is actually equal to half. And here we have it. We're going to take one more. And this is a trig identity. And looking at a trig identity that we have, it says prove that your left-hand side is equal to your right-hand side. Now, we don't have the question, but that's what the question will tell you above this line. Prove the following trig identity. So the best thing is to start with your left-hand side because there's a lot of things happening there. And then we're going to inspect it. The first one we have is cos of 90 minus x. Now that's a co-ratio, and that's in the first quadrant. So that will change to sine x. I'm going to put my fraction line there. The next to it we have a cos y. We're going to bring that down. Now then we have a minus y. And if you have a minus y, remember that's in the fourth quadrant, which means sine in the fourth quadrant is negative, and there we get our minus sine y. Then we got a cos of 180 plus x, that's the third quadrant. And in the third quadrant, cos is positive. Actually, cos is negative in the third quadrant. So then we're going to have a negative sign. Now let's just put a negative there. Cos x. Okay, we go to the bottom, the denominator, we have a cos x first. We're going to bring that down. Then we got a cos of 360 plus y. Fourth, that's going a cycle, so we can just take out a minus 360. And we're left with cos y. Then we got a sine of 360 minus x. Fourth quadrant, sine is negative. And the last one we see there is a sine y. So we're going to try and simplify that. So on the top we got sine x cos y plus, and we can rewrite that as cos x, just rewrite it, sine y. All over in the bottom we got cos x cos y minus sine x sine y. So we're now going to use the compound angle. Sine cos sine on the top reduces to sine, and it's plus, so it'll be x plus y. In the bottom, we're using the compound angle for cos, and if it's a minus for cos, we'll change that to x plus y. And we know sine over cos, the angles match, is actually equal to tan over a into x plus y. And that is actually equal to the right-hand side, as you can see. Thank you.